Hello everyone. I have great news actually. I have already recorded the first part of the tutorial, and this is what we achieved in that tutorial. Pretty amazing, right? Now the good part is that we actually were using the wrong microphone for that, so the audio is all screwed up. But worry not, guys, because this time I hopefully chose the correct one. So let's continue from where we left off, and I'm obviously going to need to tell you what we did. So we want to create a shoot 'em up game, a really simple game, just for learning purposes, just for, shits and giggles. And we chose this mini pixel pack 3 asset pack created by uh, by this guy. Okay, so if you like this and you want to use it commercially, hit this guy up, pay him or something. Okay, so we downloaded this and we are using Raylib, which is a great library, I have to say. So let's use this. We created a basic window, nothing too special. We created a scene class. Right here, I can't see this because of my webcam, but I think, yeah, this is the scene class. So we created a really simple scene class where we have, please, can you go away? Okay, you didn't even see that because it's behind the camera. Okay, so we have some objects here, obviously. We have this game object class that we created at some point. Let me turn down the volume just a little bit, just like that. Okay, we have this game object. We have a couple of objects in here. We have a method that will update all the objects and a method that will render all the objects. We also created this add function that will add objects into our scene. And let's see how this game object looks like. Ba-bow. Pretty shitty, I know. So we basically have a reference, we have a pointer to our scene, we have a position. This, in case you don't know, this is a vector tool, so it has two components, an X and a Y. Okay, let's not waste time. This is the the only constructor the game object has. It takes in the scene and the starting position, and then we have two pure virtual functions. So we are making it mandatory for other classes that inherit from this to implement these functions. So so far so good. Let's see. We then created the game object CVP doesn't really have anything. It just has it's initializing these variables. If we look in the player.hpp, we just inherit from game object. We have a texture from Raylib. We have the same constructor and we have the two methods we talked about overridden. And in the player.cpp, we actually have here, we are loading a texture from the minipack 3 stuff we downloaded. And from there, we are actually choosing the source. So, well, this is Raylib stuff, but we are basically choosing where we want to take pixels from the image and where we want to draw on the screen the things. And then we just draw that. And obviously we will have to change this because it looks horrible, but this is what we are going to be using for now because it's doing the job. And I'm always going to say this, but make sure first the things are working and then worry about making it pretty. So this is basically all we have. And here in main, we are actually creating a scene. We are adding a new player, passing in the starting position and a pointer to the scene, calling tick and render. This is the delta time. For now, we just left it 0, just because we don't actually use it for now. And what's gonna happen is it's just gonna go through all the objects and it's gonna update them. and the same thing for render, but it's gonna render them. So this is a quick recap of what we've done in the previous tutorial. Now in this tutorial, I don't actually have anything planned up. I was thinking maybe we can make the thing move. So usually what I would do is if you're using like Unity or something like that, you would have something like input get horizontal axis, right? And you would get a -1, like a -1 or 1, depending if you are going, well, the webcam is mirrored, but I'm pointing towards left now. So if you're going left or right, you have -1 or 1 and 0 otherwise. So we're going to implement the same model here. We're going to do this and get vertical axis, vertical, and let's say float. Okay, if my computer wouldn't freeze up. So horizontal, vertical, and let's actually create this input class. This is input. It's gonna be a like a singleton. It's gonna be accessible from everywhere. We have static float get horizontal axis, and well, I don't really remember how to use the keyboard with Raylib, so Raylib examples. Do we have like keyboard key? Let's see. 222 is key down. Okay, so let's do that. So if, and why this is pretty nice to have this get horizontal axis instead of checking for certain buttons in the player, is because now we can actually add support for controllers as well, just by changing this function to check for that. So we are going to be doing that in the future. So let's simply include Raylib here, Raylib, just like that. Let's say if we pressed A, or if we pressed left arrow, return -1, and the same goes for the D, otherwise we return 0. And let's do the same thing for the vertical axis. But we're doing, I think we are doing negative is up, so W and up, positive is down. Put here S, like that. And so what's gonna happen is, if we go in the player and we include the input like that, we can actually say M position. This is like the most simplest way you can do it. Position X, you know, we just add the horizontal thing times some speed that we are gonna initialize at some point, and the same thing happens with Y. So yeah, let's actually create this M speed and initialize this to 10 or something. So now theoretically, if we press these buttons, oh my god, we are actually moving. Do you see that, guys? You can see the keyboard, like I'm not lying or anything. This is not pre-recorded, just so you know. Okay. Nice. Now, again, we are just making this as a joke, like a tutorial, something. We're just bored, I guess. So, you know, the code here isn't industry standard, I would say, but, you know, I mean, it's not too bad, but, you know, it's not great either. So, let's actually create a way for us to import certain textures. So we can, instead of doing this, mTexture equals load texture, yada yada, we just say assets get texture. We say player left. Okay, that's it. That's what we want to achieve. And so let's try to do that. Let's create a new class called assets. And by the way, this is freestyle, so this is not pre-recorded, guys. Class input. So let's say static void load texture, and let's say like the path to the texture and the name of the texture. Additionally, we might want to pass in like so for example in here, if we have we go in here in the shoot 'em up, the texture pack, if we go in the player stuff, we see that they actually have 3 textures in here. So we want to specify each, we want to give a name for each of these textures. So we have to specify the starting position and the size of them if we have multiple textures in one texture. So we can specify these in here, int width, int height. And so let's include a string for now. And we also want an option where we don't have those, but we can, well, we can make them, we can put it in the same function, but I don't know, maybe this is a bit cleaner. So what's gonna happen is we are also gonna have like a static map of like the name of the texture, like player left, as I gave an example here, and an actual like a something that contains details about our texture. So for now, quickly, I'm gonna create here a class called, actually it's a struct, I think, texture details, where we actually have like the texture 2D, which is like if the backend is made in OpenGL, it's like the ID of the texture that we actually need in order to draw it in here in the draw texture. Otherwise, other than this, I meant so like the ID, and we also need here the rectangle for the source. So rectangle. So it's this part here, which I said that we actually have to define with this. Yeah. So let's see, rectangle source, I suppose. And let's include Raylib. I have no idea if this is gonna work, but how bad can it be? Let's do a map. Texture details, textures. Nice. So now we have a map of textures. Let's also create like a source file for this. Because this is static, it needs a place where we have to put it. So let's do it like that. Include assets like this. And why did I name this input? What the hell? Damn. Talking about being delusional. Okay. So what's gonna happen is we're gonna check if we have already. Well, actually no. So what happens is we actually need to cache some of the textures, because if we load this texture, we don't want to load it 3 times separately. We just want to load this texture and simply add in the details for these 3 images in here, but the texture is just one. So we don't store the same image multiple times for every frame we want to specifically have. So what's gonna happen is we're gonna use the path here as a key for the textures because they are unique. So let's try to do that. This might not be the best way to do it, but I don't know, I just quickly thought of this, so maybe it's gonna work. So if textures has this path, I mean, if it doesn't have it, well, this is if it has, and if it doesn't have it. So if it has a texture, then texture details result. This is the new texture detail we are gonna create. So we are gonna, if it already exists, we are simply gonna pick that up. We're gonna take that ID and use that, so Raylib doesn't load it again. I'm gonna say result dot. Okay, nice joke. Result dot ID is this thing. So what's gonna happen now is if we didn't have it, well, we are simply going to load it in. So we are gonna have a load texture, which I think it's the same name. So let's put in here asset texture, so it's not confused with the function from Raylib. We could put Raylib in some namespace, so there's no name collision, but yeah, whatever. So we're gonna load the path into a text, into this, like that. And moreover, we are gonna cache this in, so we are gonna create an entry for this path, so now we can reuse it in the future. We're simply gonna say we're gonna initialize this with texture details cached. We're gonna say cache.id. Oh, we can actually do it here. The ID is actually the result ID we created here, and we don't care about the other thing. And so we just initialize this, and now we cache it if we don't have it. So now this result usually how do you draw like the entire texture? Where would you get that info from? I'm pretty sure this is just an ID, right? Oh no, this is actually not just an ID. This also has like the width and height. Okay, I didn't know that. This is the texture. Oh, okay, so okay, that's interesting. So we have to change our code here, but not that much actually. We just have this, and in here we can just say result dot source is let's create a rectangle. This is the most annoying thing about Raylib, as these rectangles you have to work with. But I mean, they're doing its job, so so the x and y will be from 0 in this case, and the width and height will be from the texture. So let's do it like that. That width, and here's gonna be that height. Okay, and this is simply gonna be source, and the same will be for this one. Pretty nice. And now the texture name will be the result. Okay, we just loaded in a texture, which, I mean, it hopefully works, maybe. And now let's do it for the place where we can actually choose where the texture starts and ends. So it's simply gonna be this. However, the only difference is that when we cache the texture, we actually use the whole texture. So XY, texture width, texture height. And that's it. As simple as that. So maybe it works, maybe not. We're gonna see. Static texture details. Get texture string name, and also let's do this magic thing so it doesn't copy. All right, let's see. I think this is the least informative tutorial on the internet, man. Okay, motorcycles are quite crazy. Let's see. For now, no error checking. We're gonna make this raw and textures name. If it doesn't have it, it doesn't have it. It's just gonna crash at some point, maybe. If not, I'm fine with it. So let's include assets here, like that. Let's take this, and also this end texture has to become a texture details. And I'm just gonna say, hey, texture details is somewhere. Well, actually we can do that because yeah, it's not a pointer. So I'm gonna put it in a different header in just a second. For now, here, after we initialize the window, we can actually load as texture. Okay, that's a really long name. And we start from 0, 0, and we take 16 by 16. And that's gonna be layer left. Just like that. Nice. just like that. And let's create a header called texture details pragma once, and we just copy that from the assets. Okay, and we can include it now here, just like that. So let's see if it works. So here we should have player left. Here we should put in here texture. We should have here texture source, because that's the same thing we should have in here. And we have to fix this in one of the next episodes probably. Oh my god, it doesn't work. Okay, so it returned the whole texture, which is not what we wanted. And let's see why this happened. I think I know why. It's because when we load in and we specify part of the texture that we want specifically to be named like this, we're actually returning the whole texture in here. We are yeah, here. We are actually in the source rectangle that we specify here. We are having the whole texture, and we don't want this in this case. We only want the width and the height. But when we cache the whole texture, obviously we want the whole texture to be cached. Okay, so if we do it now, we should only have the left part of the image. And if we wait a little bit, we can actually have all the images. So let's see. This is gonna be neutral, and this is gonna be player right, like that. And what we are gonna be doing is saying, hey, if H is negative and texture is gonna be left, else if H greater than 0, it's gonna be right, and else it means it's 0. We're gonna use the neutral. And obviously this isn't how we're gonna have it in the final version, but ooh, it worked really well. Oh my god, look at that. Amazing. Okay, we definitely have some issues here. Do we have some errors in here? I don't see any. So this is really interesting. Nice. Okay, so we definitely have some issue. Let's see if we can quickly spot it. If not, we can do it in the next episode. So we have textures in here. This was found in here. Oh, I see. The source wasn't filled in, I think. Yeah. So we actually want to take this out of here. Yeah, I'm thinking, how can we make this a bit cleaner? Because here, if it's the whole image, then it needs the texture width and height. Well, in this case, we should actually have it in here. right? So that shouldn't be an issue. Now for you, you just, just create. This is really ugly. Oh my god. Yeah, this is basically the same thing. Okay. And this should also work for here as well. Really ugly. Don't really like it, but yeah. This is gonna have to do it for now. Okay, it actually doesn't work well. So we messed it up even more, if you can imagine that. Oh, I know what happens is if we already have the image cached, we are actually not populating that thing, so that's great actually. But we also have an advantage. If we only take a part of it, we actually know how much we want from it. So we can do that there. And we actually don't need it here. And in here, this is the only special case where we have to do it, because we have to load the texture. So sadly, we do need this to be different. We could change the code a little bit so it checks to see if it was cached, and so it does all this down below only once, but I don't think it matters. So as we can see, it sort of works. So yeah, pretty neat. See you next time.